So Jacopo has been working at Criteo, but what I really appreciate about Jacopo is that he has been producing artifacts. They are very pragmatic in nature that people can just pick up. For example, ops at reasonable scale, postmodern stack, and now RecList, which I think is a very important problem given that I work on recommendation systems as well, and it's sort of open source the code, but get people to start thinking about behavioral evaluation of recommendations and how to start thinking about it. And he's given some examples, and in the code you see price comparisons, and he talks about complementary versus substitutes. So that is the topic he's going to share today. And I mean, he comes from a very pragmatic standpoint. So I am very confident that whatever he talks about today, you can, if you're in RecSys, you can apply it to your work. So Jacopo, take it away.
Thanks so much, Eugene. Thanks so much, guys, for having me, and thanks so much for everybody for spending your evening or morning with us. So I'm gonna share my screen and just tell me if you see it. I prepare I prepare a small presentation, like guiding you through the problems that I want you to to discuss us together. And then of course I'm super happy to answer either online or like offline in the after party, any question you might have. So don't be shy. There's no question that is too simple, or no question that is off limits. Like feel free to ask whatever you think may help you in getting the most out of this. Well, thanks so much, Eugene. You already gave like a super good presentation, so I'm not gonna bore you with this. The only thing that I'm gonna add is that I have a fantastic Japanese-inspired avatar right now, and I'm using it all the time. So that's the only thing I want to use. And everything else, you can Google me, GitHub me, Google Scholar me, or whatever you want if you want to know what I've been up to in the past couple of years or so. I'm gonna also share these slides in the Discord after everything. So there's a lot of links in these slides, so you're gonna see them. So don't worry if you miss something, or if you want to go deeper in some of the topics, you're gonna have the slides for you to do that. So what we're gonna talk about today is about testing recommender system, okay? And we're gonna kind of have two main topics. One is the problem, and the other is a possible solution. The important part here is the problem, not the possible solution, meaning that, sure, we're going to tell you what we think is a good way of addressing it, mostly because we work on this. But what we really want you to take home is that there's a genuinely interesting but also important things that you need to think about when you do recommender system, but more generally when you do machine learning system in actual practice. Okay, so we're not going to tell you anything on how to build recommender system today. So I'm going to assume that you have a recommender system somewhere. If you want to know how to build recommender system, this very community is that like a fantastic RecSys series very recently, and of course I'm super happy to point you to relevant stuff. Last thing of an intro. So RecList has been, which is this solution is an open source project that is built by the community and for the community. The original paper and the original package has been built by Federico, Patrick, Chloe, and Brian. I am pretty sure you at least know Chloe. And right now we're working together to a beta version of this. And the beta version is actually supported by three fantastic companies in the MLOps space: Neptune, Comet, and Gantry. You may or may not know them, but I seriously suggest them to check them out. And I say this as not as a rhetorical thing, but one thing that it continues to amaze me in a very good sense in the MLOps community and this growing ecosystem that we're all part of is like how many cool things companies and people do for the community somehow to pay it forward. And so I'm super proud to working with these companies that are so forward looking that they want to sponsor the development of an open source project that have no commercial affiliation whatsoever, and they're just built for the people in this community. So I really think that is very cool that that we can do that. And I think it's a very cool thing about this field that people are so genuinely involved in the community that they want to do a lot of stuff for free and the open. So done with the intro. Hopefully everyone's on board. So let's talk about recommender system. Since you're here, I don't have to convince you that recommender system are important because you probably kind of know them by yourself. Okay, so recommender system are super ubiquitous in digital life. meaning that most of the, or a significant part of machine learning system in the wild are actually recommender system. Think about your normal life as a consumer. You go on Netflix or on Amazon Prime Video, and there's a suggestion of movies. You try to do grocery on Instacart, and there's a suggestion on how to complete your cart. You even go on Facebook, and there's a suggestion on which friends you need to friend, so which people you need to befriend or link, and which connection you want to have, right? Recommender systems are literally everywhere, okay? And you see here, so this like, they're forecasted to be like a $15 billion market, in 40 years or so. I wouldn't take this number, as a specific number. I would take it more as an order of magnitude, as all these estimates tend to be, somehow shaky. But the idea is that recommender systems are super important, okay? And I think everybody here is agreed about that. Recommender systems are also very easy to get wrong, and a lot of people are dissatisfied with many recommender systems that people build in practice. So again, another survey, take it with a grain of salt, but if you work in e-commerce, you will actually know and experience firsthand that a lot of shoppers get very annoyed when they get bad recommendation. And so what they're going to do is they're going to take their business elsewhere. So if you work in an e-commerce, you actually have a huge incentives of being good at recommender system because your shopper will actually demand that, right? And unfortunately, even when recommender systems are mostly right, okay, even one bad mistake or a couple of bad mistakes may have disastrous consequence for you. For you, meaning you building the recommender system, or you, the person that is actually, experiencing the recommendations. There are many horrifying stories out there. This is one of them, but just random sampling doesn't imply anything. And this is a recommender system that kind of picks up a pattern that is very bad. This was on the New York Times a while ago. And being an algorithm doesn't know any better, right? So even if the algorithm is generally correct, there may be some edge cases that is very hard to control for. So what do we do? So recommender system are super important. Recommender system needs to be tested properly. How do we test recommender system? And before we tell you, the new way of testing recommender system, it's important to tell you what people usually do in industry or in academia. So typically recommendations are casted as a basically ranking problem, okay? So a lot of the information retrieval metrics that are used in information retrieval, for example, in search, actually applies to recommender system as well, okay? Let's take this very, very simple example. There's a user, in this case is Jacopo, like with my failed Turing test t-shirt, okay? And we know in the test set that Jacopo actually watched a very cool series called Big Mouth, okay? So this is the gold standard. This is the truth that we need to guess. And when we train a model, what we're gonna do is that we're gonna ask the model to produce a ranking of things that the model thinks Jacopo would like. In this case, it's BoJack, Pete Mouth, and so on and so forth, right? Okay. And what we're gonna do to measure this recommender system is we're gonna check if in the recommendation of the model, the 3 recommendations you see here, there is actually the truth. There is actually what Jacopo actually enjoyed watching, okay? So this is a standard machine learning problem. You have a training set, you have an held out test set. The held out test set and some truth, like something that actually happened. So we're trying just to see if what the model predicts is part of the test. So, like, sorry, I think I got muted inadvertently. So nothing particularly weird here. So let's define some metrics. So now that we know how the testing works, let's define some metrics. So let's take a very, very easy metric, probably the easiest one, right? Very, very easy to understand. It's called hit rate. Okay. So what we're gonna do is that we're gonna ask how many times basically of the entire prediction sets the model actually gets the correct one. Okay. So let's say we have 2 examples here. So there are 2 testers. So we have 2 data points in our test set, and the first is the prediction of the model that actually contains the tester, and the second one it doesn't. Okay. So in this case, you have 2 prediction, you have 1 hit. So hit rate is like a half. Okay. Hopefully very easy to understand. What is the problem with this metric? The problem with this metric doesn't really take into account the fact that your prediction is going to be the first item, the second item, the third item, or the fourth item, right? All items are treated the same in the prediction set. Okay. So what people may do is that, well, let's take into account, like how high is the actual test set in your prediction. So again, you have the same type of problem, okay, here, you see here, and you have the same test root, so test root 1 and test root 2, and you have the model output. And in this MRR version of the matrix, what you're gonna find out is that the second part, the first part is not just correct, but is like, in the second position. So Big Mouth is not just the correct movie, but is also in the second position. And in the second part, the prediction is actually wrong, and then you do the calculation and so on and so forth. Okay, so it's pretty standard. It's pretty standard information retrieval metrics, and this is what most people do. So what is the problem with this line of thinking? Well, information retrieval metric generally won't consider anything above the fact that your target item, Big Mouth, is in the recommendation. But this is a problem because sometimes recommendations are not just bad, but as we said, they're deeply logical. Like the problem is not that the recommendation is just wrong. It just is really stupid from the point of view of humans. Okay. So take, for example, this is a real screenshot. It comes from my LinkedIn feed, I think, that somebody posted to kind of complain about the state of recommender system. Okay, this is a recommendation for a job, right? And we're recommending a job to a CTO. And the job that we're recommending to the CTO is executive assistant. The problem with this, again, is not that this is not a super relevant recommendation. Is that this recommendation is plainly dumb. Like it's something that no human would ever consider appropriate to this particular thing. Okay, and there's no way for any of the metrics that we discussed to actually reflect this problem. Things are even more subtle when you consider then sometimes even the fact that the model is right is kind of misleading when you think about user experience. Consider these two carousels of movie, right? So there's a test route here, which is when Harry met Sally. I apologize in advance because most of my references come from the 90s because I'm an old person, but you can think about this example with, I don't know, Harry Potter or something else if you prefer. So the test route here is when Harry met Sally. And we have two models, model A, model blue, and model 2, model red, okay? And these two models make 3 predictions. In both cases, these two models actually guess the correct item, right? Is item number 2 in both carousels, right? But there's an argument to be made that model 2 is a much better carousel than model 1. Even if technically they both guess the same, they have the same hit rate, the same MRR, okay? But model 2 somehow guess the general vibe of what the user wants, which is romantic comedy with Meg Ryan, okay? Well, model 1 guess the right one, which is Harry Met Sally, but is also mixed with movies that do not really mean much for potential people, okay? So there's no way for metrics like hit rate or MRR to make a distinction between model 1 and model 2. And this is a problem because we believe that our experience of people actually depends on these subtle things as well, okay? So hopefully I convince you that the standard way of thinking about this is not the entire story, okay? And the question is, how can we be better at this? Like, is the standard quantitative testing doesn't tell the entire truth of a recommender system? How can we be better? And the solution, well, one solution that we propose is going towards behavioral testing. And we're gonna go to explain what behavioral testing are before actually seeing that in recommendation. So what are behavioral testing? Like, let's say that instead of taking our dataset, train split, test split, and then we make a calculation on the test split on hit rate or MRR, what we're gonna do is we're gonna produce some examples of input and output that we believe the model should actually be able to solve. And then we're gonna try to evaluate how the model does on it, irrespectively of the actual inner working of the model. It's also called black box testing. Let's see this with an example in NLP, where we actually get the idea from RecList to explain exactly what we mean. Okay, take the first example on the left, right? This is a template filling test. So the template is I am a protected noun. Okay, so there are 2 slots to fill. And then what you're gonna do is that we're gonna fill these slots with protected words and standard noun. For example, you can complete it with I am a black woman or I am an Asian man. Okay, and the crucial aspect of this test is that it may be fairly unlikely that in your text classification data set, you have exactly these two sentences. So what you're gonna do is gonna test the model, and to test if the model is the proper neutral stance around this in these two sentences, and you're gonna check what the model does. Or take the example on the right, which is like a transformation between like a standard affirmative, like declarative sentence and a question, right? So the first question is the pilot wasn't fantastic, and your model says there is a negative sentiment. But what happens if you swap things around and say, was the pilot fantastic? No. Well, we would expect the model to have the same sentiment, right? Because for humans, these two sentences are completely equivalent, okay? So again, the idea here is that since it's gonna be very rare that the test set is gonna actually contain a sentence like, was the pilot fantastic? We're gonna create this sentence and we're gonna test the model on it. So the question is, what happens when state-of-the-art NLP models are tested on this type of questions and not the test set that, the standard way of testing? Well, it turns out that many models, including, like open source model that people use all the time, or APIs in the cloud, like Microsoft, for example, they fail most of the time this very simple test, okay? So what happens is that when we evaluate the NLP models just based on the train and test practice on a data set, we may actually overestimate drastically the performance of this model, okay? Machine learning models and recommender system are no exception, are very good at picking up patterns within a distribution. So if your test set and your training set comes from the same distribution, basically, because you just randomly split some data set, it may be that you perceive the model as being very good at what it does. But then when you deploy the model in the real world and the model encounter a sentence like, I'm a black woman, I'm an Asian man, the model may actually fail spectacularly in that. But since you have never seen this sentence in the test set, you will instinctively overestimate the performance of your model. So what did we learn from RecList, the NLP behavioral package by Microsoft? So first, behavioral testing improves reliability. So it doesn't matter what you found in your training distribution. It doesn't matter what you have in the test set. There's some human knowledge that is very valuable, and you want your model to be good in that part of the, on that part of knowledge, okay? So irrespective of what your test set says, there's a lot of tests that you may want to use to actually understand how the model is doing, okay? The second part is behavioral testing is hard. Imagine, so go back here, imagine of building manually, like a sentence like, I'm a black woman, I'm an Asian man, or like doing the paraphrases, like the pilot wasn't fantastic, and so on and so forth, like doing that at scale. Like it's a freaking pain, okay? So what the Microsoft package tells you is that there are some tricks and good practice you can use to scale test up, okay? So behavioral testing are important, and you don't have to do them all by hands. So that's kind of the two insights here, okay? So what do we do now when we take that insights and this problem and we apply to recommender system? And this is the part of the solution that I was mentioning in the beginning, which is less important. Like if you want to use our package, or if you want, if you want to use that, of course, we're super happy. But the most important thing is that we all agree that this is a problem and we kind of need to be better at this, okay? So RecList is, you may call it checklist for RecSys or like whatever you want, but it's kind of the idea you can bring together best practices for reproducibility in research and robustness for deployments, okay? We build it over 3 pillars. One, it needs to be open source, always open for everybody. It needs to be peer reviewed. So there's a paper that has been accepted and presented at a web conference this year that kind of explain in a scholarly way, so to speak, the problem and what we think of addressing it. And again, as we said in the beginning, is a project by the community and for the community. So, with a lot of people with a diverse background that kind of contributes to this industry, academia, more senior people, more junior people, kind of all working together towards this common goal. What do we want to do with RecList? With RecList, we want to enforce behavioral principles that we know are important so that people can make good decisions about the recommender system, okay? And we're gonna see some example here. So example number one, it's ubiquitous in recommender system in practice, okay? And if you do movie recommendation or book recommendation or music recommendation, you're gonna find out that the vast majority of the items in your catalog are very, very rarely consumed by your customers, right? For example, in Spotify, I don't know, Beyonce and 50 Cent account for a disproportional number of people listening to them. And then there are like a million songs that have been listened one or twice a day. And that's the same with movies, right? Even if you take like Amazon Prime Video, there are going to be few movies that are going to be responsible for the vast majority of viewings, and a lot of other movies that are actually very rarely seen. Why this is important? Take for example these two models here, model blue and model red. Okay, and these two models make prediction over blockbuster superhero movies and over niche Italian movies from the 50s. Okay, when you do the math, like again, this is that toy example, but you can totally see that like in a scale up fashion. So when you do the math, you're gonna find out that these two models has exactly the same hit rate. So if you take a standard quantitative measure on this data set, you're gonna find out that model blue and model red has exactly the same hit rate. Okay. But now what happens is that if you consider the split between the performance on the blockbuster movies and the performance on the Italian movies, you're gonna see that these two models are actually very, very different. In particular, if you improve, when you go from blue to red, if you improve a tiny bit your performance on blockbuster movies, you see here going from an hit rate of 0.5 to 0.56, even if you destroy the experience of people watching Italian movie, your hit rate is gonna be the same. What does it mean? It means that if you judge your recommender system only by one number in your test set, a small tiny improvement in the most popular category, like Beyonce or Marvel movies or whatever, are gonna have a disproportional impact on what you perceive as the performance of your recommender. Which means, saying in other words, is that you may end up, kind of destroying the experience of a lot of people that are kind of smaller group, niche group in your audience, just because you get this tiny, tiny marginal gain in, Marvel movies or whatever. The point here is not telling you that blue is necessarily better than red. That really depends on what your company is doing, what you're trying to optimize. The point here, making sure that this discussion is happening. That when you push a new model in production, you're testing a new model, you know where the gain in performance comes from. If it comes from the popular items, or if it comes from the long tail, or a mix of both. Okay. The point of RecList or of any behavioral testing is not necessarily to tell you what is better, but to make the discussion explicit and somehow principled. So another problem and principle that we may have, which you kind of touched on it before, is what we call being less wrong, okay? And this is idea that some mistakes are kind of worse than others, right? Again, let's consider the romantic comedy example. The test case is When Harry Met Sally is the right answer. And then we have two models. We have model blue and model red, okay? They're both wrong. So when we consider these predictions from the point of view of hit rate of MRR, this is a 0. I hope everybody agrees. This is not getting the right item. But there's a very important point here. The one is a bad prediction, which is the blue one, and one is a wrong prediction, but it's very reasonable. Again, if you imagine to having like a latent space, a space when you put movies together, you've got mail is going to be very, very close to When Harry Met Sally. Okay, so sure, the model was technically wrong, but if we use a standard metrics, there's no way for us to still give model 2 the credit for a good guess versus a completely wrong thing. I know a lot of you are still young enough that you probably remember your university days, and if you remember when you have like an exam, there's a difference between giving a completely wrong answer and being an answer that is close enough to the right one, even by not being the right one. And what typically your professor will do is that will you acknowledge the fact that you get close to it. So you're going to get some points for it. Like you're not going to get the full point because you didn't get the right answer, but you're still gonna get some points, okay? And this is kind of the same idea, but for models. But imagine this doing it on 100,000 data points on your, on your catalog, instead of doing it like 3 times for your, calculus exam, okay? So with this in mind, what happens when you actually try to operationalize this idea in a package that people can use, and hopefully a package that people can use very, very easily, okay? So RecList is a simple Python package that is basically composed of classes that inherits the RecList abstraction. And what you actually find out when you work with RecList is that the RecList is just a list of tests. You can see here like this very simple declarative syntax. It's kind of very similar to Metaflow if you know Metaflow. So what you basically have is a class with some tests. Tests are decorated with the test decorator, okay? And the tests are basically able to read inside your, the train test and metadata of your data set, and kind of calculate statistic that you can actually use, okay? We already provide you ready-made abstraction for popular data set. So for example, if you really like movie lens, we already provide you a RecList for that, so you can start with that. But of course, the framework is kind of agnostic, and you can include your own data set and your own tests, as much as you want. When you actually use it, it's fairly easy to run your test on your model. So this is an example when we actually use the Coveo dataset, which is a built-in dataset that we provide. And in 4 lines of code, you can basically get the dataset. You can train a baseline. If you don't have a model, you can train one of the models that we provide. And then at the end of the script, you just instantiate the RecList, and you're gonna get basically all the results for you. If you don't want to install anything, we also provide a Colab tutorial from the GitHub account, so you can kind of walk through it in the browser and get the feeling of how it works. Let me see, how am I doing on time? Okay, yes, I think I'm good. So what is the idea of RecList as part of the MLOps world, right? We imagine this as being just one of the many ML tools that you use inside of your machine learning pipeline. If you are kind of following us, on the artifacts that we produce, we've been shipping out recently some, I think, cool open source project in end-to-end recommender system. If you guys are going tomorrow to the NVIDIA Recommender System Summit, we're gonna present it actually tomorrow. And RecList can be just one part of your machine learning pipeline. If you're using Prefect, if you're using Metaflow, using Airflow, running RecList, running behavioral tests should just be part of the normal pipeline that you have when you build your model before you deploy, okay? So when you run RecList, what happens? There are 2 things happens. RecList is gonna produce some charts for you, like the one that you see here. But also RecList is gonna produce basically a big JSON, which is a machine readable dump of all the tests and all the results that actually happen during running RecList. And what we're gonna build, like in our beta, is connectors from that dump to popular framework, for example, Neptune, Comet, Gantry, for people to have the results of RecList inside tools they already use. So our roadmap and our vision for this is that RecList is gonna be hopefully part of your normal toolkit, and you can just pip install, you can just use it, and then you can get the fruit of RecList. You can get visualization just for free by using tools that you may already use for other reasons. I can skip this. So what can you use RecList for? Or what should you do with behavioral testing? If you're doing research, as in you're building a new algorithm or you're publishing a paper, we would love for people to not just post the usual table with MRR, but also to try and understand through RecList or similar principles, like why their model is better or worse than other models. So we think RecList can help in experimenting, reporting, especially because it comes with a lot of pre-built stuff for data that people use in research. But if you're in industry, or if you're kind of like starting to understand the MLOps ecosystem, and you're trying to build tools that people use, you can also use RecList as part of your normal pipeline, as we discussed, right? So you have your training phase, fine. You have a quantitative test, standard MRR, iterate, NDCG, whatever, okay? But then you can also have rec tests just to make sure that before you deploy something in production, like the model actually does what it's supposed to do. Okay, and of course there's a monitoring and debugging component to it, which is, well, after you ship your model, you can still continuously run some rec tests to verify that the model actually is doing what it's supposed to be doing, or debug things when things go wrong. Okay, because unfortunately things may still go wrong. Doesn't matter how many tests you try to build before you ship stuff. So what are we doing right now? We released the alpha in January. We had a couple of feedback by friends in some recommender system team. We presented a paper at web conferences, and now we started doing some public talks like this one, for example, to talk about the problem and make people aware that there's a new library they can try and use and give us feedback. And the next step is building the beta, which we're building, and I'm happy to provide some details of like what is going to change in the library with the new version. And we organize, and we're going to go through that in a minute, a new data challenge at CIKM, so a top tier conference about evaluating recommender system. Okay, and we're going to use RecList to help people build a good evaluation. So finally, and then I'm going to shut up and hopefully open the floor for many interesting discussion and question. So I tell you what we built and what we're trying to do, and the question is, what can you do to be part of this if you want to be part of this? So first, the CIKM Data Challenge. So people from academia and industry, again, Stanford, NVIDIA, Microsoft, Coveo, Bocconi, came together to give you EvalRes, which is a new type of data challenge that is going to be taking place. It's going to start in like 10 days from now, and it's going to run until basically the fall, when there's going to be CIKM in Atlanta. Okay, we're going to soon announce prices and perks for people participating in it, but we think it's going to be the first of its kind challenge when we ask people to submit models that are not just accurate in the standard sense that we discussed, but they're also fair, they're also unbiased, they're also balanced in the way they treat different type of groups, and we will try to give back to the community everything that we built for the challenge. So all the challenge is built in the open. So the evaluation script, the models, the data, everything is open source, and all the solutions are going to be open source as well. So this challenge is totally for the community, and everything that we do as part of this challenge, including the workshop at the end of CIKM, is going to be given back to the community as part of our effort of kind of evangelizing on this. So if you guys are passionate about this problem, or if you guys like data challenges and want to kind of like test yourself on this new type of challenge, please go to this website. I can post it there in the chat. As you join our Slack for the challenge, because we're gonna soon announce prices and the rules, and I'm gonna kick it off. Of course, other things you can do if you want to be part of this, check out RecSys on GitHub. Again, it's all open source and it's all free to use. If you like this talk, or even if you didn't like this talk, but if you just want to support our effort, please give us a star, because it's very important for us and our sponsors, that the project is known and is shared. And of course, if you in your company or somebody that are working a recommendation system, send them a link and see if they may have some use for it. And of course, if you use it, please reach out to us with some feedback. Okay. I think I'm gonna shut up finally, and I hope it was a good overview of the problem, and I'm super happy to take any question whatsoever on recommender system or testing anytime you want.
It was a fantastic overview, Jacopo. Thank you. And we have a few questions in our Slido. So I guess a first question I have, and the questions are a mix of business and programming. Sure. And of course, please post additional questions there. That's the only way we're accepting questions now, because of Zoom bombers, and we'll be sure to go through as many of them as we can. So I guess a question I have is, RecList, you compute business metrics and etc. Have you found a way to relate this statistical metrics and test with your business KPIs? How well do they correlate, or how do you think about them?
That's a very good question. So marrying information retrieval metrics and general business KPI like offline, I wouldn't say it's impossible, but it's very, very hard. And in my experience, the last word about the business impact of information retrieval system is online testing, which typically is done through, A/B testing or or some sort of causal analysis and so on and so forth. So the short answer is, what you can do is to test important things that matters to you as a business from a qualitative perspective. For example, making sure that some niche is respected, or making sure that, not stupid stuff goes online. And there's a lot of things you can do in the offline setting, like through behavioral testing to do that. But then the last word is going to be, for your business metric, is always going to be online, at least in our perspective. I also going to add one thing that it may be more contentious, but at reasonable scale, there is, if you guys work in a recommender system that doesn't power like 100 bit like Alibaba, okay, but like a normal website, okay, my experience after running a lot of tests live is that even very good recommender system tends to improve engagement, loyalty, click-through rate, and general customer satisfaction as measured in many dimensions. But the uplift that you get after you optimize a bit in the conversion rate tends to be on the 2-5% or something like that. I personally never seen huge increase in conversion rate just because of pure information retrieval metrics. Okay, that's my honest experience. What I see is huge engagement metrics, or people stay longer on the website, people explore more. So also when we consider business metrics, I think it would be, we need to be kind of open-minded of what it means to provide a good experience, and just not fixate on a couple of revenue metrics, which are of course super important, but again, they don't tell the full story. For the same reason that MRR by itself doesn't tell the full story. So I hope that makes some sense.
Thank you. It does. And I have follow-up questions with that, but I just want to make sure we go through this question first. So I guess Emma asked a question, code structure. Is there a reason why, your data set, your Coveo data set is defined as a class and an object, as opposed to, just load methods, right? I mean, what was your thinking about that? How do you structure it to the user API? How do you think about user experience?
Yeah, so this is a huge topic for us, and the true answer is that we're kind of fairly unhappy with how things, like the reason why we're recoding mostly all the classes from ground up is we're fairly unhappy with the first version of it. The first version of it, you know the saying, like, if you're not ashamed of what you shipped, you ship too late, and I think it's true. So the first thing that we shipped was great because it kind of gets the discussion going, get the numbers for the paper and get kind of like a good sense of what the community wanted. Without that, we couldn't get feedback. But the truth of the matter is that it's kind of a cumbersome thing to use because it kind of doesn't use a lot of things that people are used to in this community. So what we're rebuilding in the dataset part is kind of making dataset more similar to, Hugging Face, to other dataset class, we don't say classes, but abstraction that people are kind of more familiar with. And the biggest usability thing that we're changing is that now the new tests are basically data frame based, as in you read and you output basically all the data frame, because people are very used to reason with these pandas or das QDF kind of thing, and we get kind of GPU speed up for free if you have this sort of thing. So we're kind of migrating this to a more standardized API, and the question is very good. As in, we do acknowledge that we have some work to do on that, and we're working on that as part of our beta. So thanks so much for the question.
So one more question that's around structure. How does RecList structure the data? Is it similar to information retrieval queries? Like with corpus queries and query relationships, or is it more tabular? Do you expect a tabular format? Yeah. And you might want to think about that.
Of course. So I mean, most recommenders, again, I may be a bit skewed in this because my experience is mostly in e-commerce, which I understand is a huge part of recommender system, but it's not the entirety of the entire of the story. So in my experience, recommender system can kind of be represented fairly well by tables in a fairly structured way. because at the end of the day, you're going to ask to pick one item or a couple of items, like, from a class of like, movies or like, or like songs or something like that. And a crucial aspect of RecList, which I really like, is that instead of considering your test set as this data frame where you have, I don't know, users and the song they listen to, and you have to guess that. Since we have this data frame and we have representation about users and the item, we can actually join this with metadata and be able to slice and kind of group things very easily. Okay. So imagine instead of having two columns, user ID and songs, you have albums and you have, gender or zip code or whatever. And now you can basically do, instead of doing just MRR over the entire set, you can slice and dice and kind of understanding how this work together. So mostly I would say tabular, because I think a huge part of the lesson learned with RecList is that joining user and item information adds a huge value for people in debugging and monitoring how recommender system actually perform.
Awesome. That's all the questions I have on we see on Slido, but I guess maybe I might sneak in a question on myself. So I think you mentioned, less wrong, right? You mentioned this measure of less wrong. And I think in the paper, if I understand it properly, your less wrong is, cosine distance. If it's closer, it's less wrong.
Yeah.
I guess the question for you, Jacopo, is how do you think about using this metric of less wrong and, thinking about diversity and serendipity and of course, this less wrong metric is probably not the only metric you use, but it is sort of, bringing things more towards relevance, more towards similar things. What's your thinking on that, and how does your team think about that?
So very good question. I think being less wrong is one of the things where we're passionate about. But so the general idea is this one, is that if you can build, there's a big if, but like if you can build a latent space that somehow represent the semantics of your item, movies or songs or products in Amazon or Alibaba, I think there's an argument to be made that this latent space can be very useful on several levels. The first one is what I showed, like, when the model is wrong, how wrong it is, right? So we do not want the model to, like, if the model is right, and it's fine. But the real question is, like, when it's wrong, is it reasonably wrong or not? The second thing you can do is that using the same idea to see how diverse a carousel is. Okay. So now imagine you have a latent space, okay, and the model, and you even have the right answer, like you have three items, and one of the items is actually the correct one on the test set. But another thing you can ask is, like, how close are the other ones, the ones that are actually not the one picked, to this item, right? And there's an argument to be made, and you can make it as like, there's some virtue in having diversity in your prediction set, okay? And what does diverse mean? Of course, it's up for discussion. But if you have a latent space, you can somehow try and measure, I don't know, the region of the space that is kind of like covered by the 3 points, or like whatever you want to do. But I think there's a lot of value in having a gradual, like in treating recommendations some sort of a continuous problem and not of a discrete one, right? Like, at the end of the day, in a test set, you need to guess when Harriet met Sally, but what you really want is getting something that is a romantic comedy with Meg Ryan. You know what I mean? Like, at some point, I think there's this distinction of, like, sure, the discrete system, because at the end of the day, you have to make a choice out of a discrete set of elements. But I think there's a gradient aspect to it that often is, that is neglected by most metrics, as it not all items are like close enough. So, that's the way we're trying to operationalize it. And you can do it at different granularity. So in our CAKM data challenge, for example, is a music recommendation. So there's a user and you suggest a song. But when you're wrong, you can do this in different way. You can say, well, this song is wrong, but how close is this song to the real one? Or how close is the artist that produced this song to the artist that actually produced the right one, or the album, or whatever. Like, if you have different level of representation, you can do that at different layer. In an e-commerce, it will be not just the product, but the brand. Like, if I have a watch and if I have a Rolex and I suggest just watch, it's not just a wrong item. is a brand that is completely out of tune. If I suggest you an Omega, it's still wrong, but it's kind of much closer to Rolex than a Swatch.
And I agree. I think less wrong is the concept that I'm thinking a lot as well. And it's coincidental that we both had stumbled upon embeddings, as a way to measure distance. And the question I have for myself is, hey, if I'm gonna do this, am I just gonna make all my recommendations more and more homogeneous? So I just wanted to probe yourself on that on that as well. And I guess one other question I have is, when you're considering this concept of less wrong, do you just take the last item as the context, or do you take the entire user sequence? I mean, there's a trade-off with cost, but you also don't want the last item. It could be just an outlier. Maybe my child played this song, or I'm buying this book for my child and not for myself.
Yeah, like absolutely. Like if you just take in this case, if you just take whatever is in your test set, right? However you split it, let's say you split it by time windows as it typically done, right? And then you have your prediction, and your test set is going to be the next item is going to be, yes, like a book for your kid or whatever, and your recommendation is going to be instead like a Stephen King book, because we don't know you're buying a book for your kid, but we think you're buying a book that, well, in this case the model is going to be pretty wrong, right? But of course, in that case, it was also a very hard thing to do, and the point is never to analyze one single prediction, but imagine of doing this on 100,000 books on two models, and you're going to start seeing very different results. My point is, you have to always consider that you're not really looking at one specific case, but in aggregate over like a million books, you're going to find differences. If you look at the paper, you find out that two models that are basically exactly the same, which is not a toy example like the one that I showed, but it's a real example. Two models that are basically the same for NDCG, MRR, and so on. When you actually look at things like less strong and so on, are very, very different. So in the aggregate, you're going to see the models are very, very different in these measures, even when they're basically indistinguishable from the point of view of quantitative metrics. And again, our job is not to tell you which one is the best one, but it's to make sure that you understand that these two things are actually behaving a very different way.
Awesome, thank you. And Chip has a question. I guess at this point in time, I just want to quickly share with everyone in the audience our thinking of how to let live participation. I think Chip sort of stumbled upon a great way. If you want to speak, please raise your hand and please turn on your camera so we can verify that you're a real person, and then we will allow you to unmute yourself. Go ahead, Chip.
Cool, thanks. So thanks, Jacopo, for the great talk. So I was late, so I'm not sure if I asked a question that we already talked about, but I'm curious. It's like I recently have seen so many recommender system startups like providing recommender systems as a service, and I know that Coveo isn't so one company. So I'm curious, like from the perspective, when should a company build their own in-house recommender system, and when should they consider a service?
So I think the first question is recommender system a strategic part of your company that you need to ask? As in, you're gonna see your company value whatever that is hinging on being good recommendation? Yes or no? I think some cases are clear cut. I have an e-commerce that makes $1 billion a year. Yes, you need to build your recommendation. Fine. I think there are cases that are clear cut on the other sense. I have a Shopify, shop with 100, like 100 items. Like, let's not build a recommender system. And I think the cases in between are the one that your company culture, or whatever, the type of things that you do are gonna dictate the choice into that. My suggestion generally is that if you're not sure, buy first, because you can always go back. Like buy first a SaaS provider is gonna kind of abstract away all of that. There's many good ones. Sure, Coveo, Algolia, Lucidworld, like there's many, Bloomreach, there's many good, like they have different, they're different, let's say, sweet spot, but they're all good providers. And if you decided that after 2 years, this is part of your core, you can always go back and say, hey guys, I'm gonna build it myself. If you do the other way around and you're not sure, you may spend 2 years even like shipping a recommender system into production is gonna be a disaster, and you don't even know if it's gonna be useful. The good thing about software that you buy is that you can fail fast. You can put it online, you can see if it's working. And then once you have an idea that this is actually working, you can say, well, maybe I should do it myself. You know what I mean? So I would be very pragmatic in all of this. Typically, if you ask the question, you should probably buy. Like if you're asking a question, should I build a recommender system? It means you probably need to buy it. It's also fairly hard. Like again, sure, I think it's becoming easier to build that. My entire talk tomorrow at NVIDIA is telling people that it's actually easy to do that. But it's easy for a certain type of, I wouldn't say it's easy generally speaking. It's easy for a certain type of people to do that. But it may not be the people that that you have lying around in your company just doing nothing. So
yeah, can I just chime in on that as well? I think, to hire the people to even do that, that's very expensive and that's a very long lead time. Whereas you can just quickly buy something off the shelf and, quickly demonstrate that, hey, with this recommendation widget on the homepage or etc., we increase conversion by 2x, and that gives you a data point to consider, building a team to do it yourself. If the vendor provided solution does not meet, if you grow out of the vendor provided solution.
Does it make sense, Chip? Okay.
Oh no, I'm so sorry, Chip cannot unmute herself. Okay, I think that's all the questions we have on the Slido. We're gonna end the live stream now. And of course, we're gonna go into the after